Good day, everyone, and this will be the third episode that we have for tonight. What we're going to discuss is about balancing each of the following chemical equations. So, we're going to do a chemical equation balancing. Okay, so to start with, these are the problems that we have number 1 up to 6. So we're going to solve each one of the equation. We're going to balance them. So the first one is, let me adjust my screen. All right. So that will be magnesium plus oxygen, and the product is magnesium oxide plus the oxygen. These are the reactants. They belong to the left side of the equation, and then the product is magnesium oxide. So the technique in balancing the chemical equation is this. So you have to write first what are the elements that is involved in the left hand side and the right hand side of the equation. So for this first example, we have magnesium, then we have also oxygen. So for the magnesium here, the coefficient or the number of magnesium in the left hand side is 1, the oxygen is 2. On the product side, there's 1 magnesium and 1 oxygen. So how do we balance the equation? We have to write first, or we have to check which of the elements are already balanced and which are not balanced. Then, in this example, for oxygen on the left hand side is 2 and the right hand side is 1. So this is the element that is not balanced. So what we're going to do is multiply number 1 on the right hand side in 2, so it will become balanced. However, because your product is a compound, that means the number of magnesium also on the product will become 2. Okay, if we're going to write it here, the coefficient. So it will become 2. In that case, the reactant of magnesium on the left-hand side will become 2 also. In this situation, the equation is now balanced. So we're just going to write 2 in magnesium. We leave oxygen. Oxygen on the other side is already 2. So this is already balanced. For the second problem, we have here a combustion reaction, C3H8 plus oxygen. Of course, the product of combustion is carbon dioxide and water. So you write down first the elements on the left hand side, the number, and also the right hand side. You divide it. In this case, carbon, hydrogen, and oxygen. Same also with the right hand side. So the carbon is 3, the right hand side is 1, hydrogen is 8, the hydrogen on the other side is 2, and the oxygen here is 2. However, in this situation, the two products, the carbon dioxide and water, has also oxygens. So that means we're going to write 2 for the carbon dioxide, then plus 1 for the water. If we're going to balance this, we start first with carbon. Here, we start here. So that means carbon is already 3, and oxygen, there is an addition for oxygen. So there is 3 also here on this side. Here. Okay. Hydrogen on the left hand side is 8. On the right hand side is 2. That means we have to multiply this with 4 to make it balance. Okay, so we write 4 on this side. One second. Oops. Okay. 4. Okay, so to make it 8, so 8 on the left hand side also. However, the concern that we have, this is a bit difficult as long as the problem is combustion, or there are the product has also the same has a number of element, usually oxygen or hydrogen, or normally that's the elements that needs to be balanced on the product side, because it can be divided. Okay, so on this situation, we have here already 6 plus 1, that's 7. However, oxygen on the other side here, or the hydrogen, we added 4 to make it balance. So that means we can have here 4. If you're going to total this one, it's 6 plus 4, that's 10. So that means you're just going to write down 5 for oxygen. So 5 for oxygen here, 3, 4. All right, that's balanced already. Let's check. 3 carbon, hydrogen 8, it's 8. Oxygen is 10, that's 3 times 2, 6 plus 4. Oxygen, that's 10. So that's already balanced. Now, let's go for problem number 3. For the problem number 3, you have here calcium hydroxide plus plus HCl. Then calcium chloride is a product, and water. So if you're going to write it down, left hand side and the right hand side, we have here calcium, oxygen, hydrogen, and chlorine. We have one calcium also on the right hand, 2 oxygen on the other side is 1, hydrogen is 2 plus 1, that's it here, for the HCl, the one of the reactant. And then the other side has 2, and the chlorine is 1 and chlorine is 2 here. So let's double check first. For the oxygen, because calcium is already balanced, so we have to balance the oxygen. So we have to multiply 2 on the right hand side under oxygen to make it balance. And then for the hydrogen, so you can see that's 2 and 1. All right, so get it easy here. Let's just try first the chlorine. So we're going to multiply chlorine here with 2. So that means your hydrogen on this side is already multiplied by 2. So that's a total of 4 for hydrogen now. And that means here we have just to multiply it by 2. All right? So let's check. Calcium 1, oxygen 2 on the left hand side. The right hand side also has we're going to put here 2 because we're multiplying it by 2. So there's 2 here. So oxygen is now balanced. For chlorine, we're going to multiply 2 on this side, on the reactant side for HCl to make it balance. And then, let's see, calcium 1, 1, oxygen 2, oxygen 2, hydrogen 2 plus 2, 4. That's 2 times 2 on the right hand, so that's 4 also. So this is already chlorine. For chlorine, it's already balanced. Okay, now let's go for example number 4. So for example number 4, that is aluminum plus lead nitrate, subscript 2. The product is aluminum nitrate and lead. This chemical equation is an example of single replacement, because aluminum will replace lead, so it can have the NO3. So the product will be aluminum nitrate, and then the lead will be left out because it's a metal also. So to balance this, the element, the left hand side, the right hand side. Okay, for the aluminum, lead, nitrogen, oxygen. For the aluminum, that's 1, 1. The lead is 1, 1 also on the other side. Nitrogen is 2. Nitrogen here is 3. And then the oxygen is 6. The oxygen on the other side is 9. So what should we do? Let's go first for the nitrogen, because this is the one that is not yet balanced. So we're going to multiply this by 3. This is by 2. So you're just going to multiply it against the other side number. Okay, so that means because nitrogen is a compound with lead, that means lead will be multiplied also with 3, and the other side is 3. This one, this. Okay, so if this is what we're going to happen, let's check first with oxygen. Oxygen on the left hand side will be, if there is 3 already here and 3 here, oops, sorry, let's see, 3 here, oops, okay. So that means if you're going to count 3, the oxygen, that's 3 times 2, that's 6 times 3. So 6 times 3. Yan. And then if we're going to check, oxygen is ready. 6 times 6, 3 times 3 is 9. So this is already 18. So we're just going to multiply it by 2 on the other side. However, aluminum will be affected also, so we have to put it here 2 and 2. So aluminum will be 2, lead nitrate 3, aluminum nitrate 2, and lead will be 3. So let's check. Aluminum 3 at 2, lead 3, correct, nitrate, nitrogen 6, then this is 18, this is 18. Okay, this is already balanced. Let's go for example number 5. So for example number 5, we have here aluminum nitrate again. This is a bit longer chemical equation. And then sulfuric acid is one of the reactant, and the resulting product is aluminum sulfate, Al2SO4 3, and then nitric acid, NO3. How would you determine the product? One of the question. So let's say you have here aluminum, and this is the subscript for the anion. So that means aluminum has a positive 3 atomic number, or the atomic number is positive 3. So that means your product, if we're going to do a double replacement here, the aluminum here will connect with sulfuric acid, or SO4 disulfate. So that means the nitric acid, or in the nitrate, on the other hand, will be connected with the hydrogen. Okay, again. So if this is your equation, in double replacement, the aluminum here will be joining sulfate, the sulfate SO4, and then the NO3 will be joining the hydrogen. Okay, so that's why it's nitric acid, HNO3, and aluminum sulfate. How would you determine the subscript that you're going to use? Because in aluminum here, there's only one, then the others, the product has two. So here, this one should be, it's supposed to be like here. The -2, that is the subscript, or the upper script of the sulfuric acid, or the atomic number. And then there's one supposed to be here, so that means there is +1. So there is 2 hydrogen needed in order for it to balance with the sulfate SO4, because it's -2. So that means +2 minus, and then the -2, so that's a 0 charge already. Okay? But if you're going to do the balancing, let me erase it again, so it can be clearer for you to understand the equation. Okay, again, that's aluminum nitrate. That's 3. And then H2SO4. The product is Al2SO4 3 plus HNO3. Okay. For the element, left hand side, then the right hand side, we have here aluminum, nitrogen, oxygen, hydrogen, sulfur. So for the aluminum, you have 1, then 2 on the right hand. Nitrogen has 3. Nitrogen here has 1. Oxygen has 9 plus 4 here, 4. And then on the other hand, on the right hand, there's 12 plus 3. All right, but hydrogen, we have 2, and the other side is 1. Sulfur has 1 and 3. So what we're going to do first, let's check first which of the cations has not yet balanced. So for the aluminum, we have 2, then the other side is 2, that's 3, so we multiply it by 3. Not yet, not 3, because if we're going to check it here, aluminum has 2 here, and nitrogen, that's 3, 6. So that means this is multiplied by 2. This is multiplied by 6. Okay? Based on the cation aluminum. And for the, let's go first for the hydrogen. We have here 2. Then we have here 1. Nitrogen has sulfur. Let's go for sulfur. Let's go first here. So that means we're going to multiply this by 3. So this is multiplied by 3. This is multiplied by 6. So it can be balanced. In that case, the oxygen for aluminum nitrate is multiplied by 2. The other one is multiplied by 3. This is 3. So that's 18 plus 12. Okay? So that is 18 plus 12. So we have on the right hand side is 12. Then we have 3. So we're just going to multiply it by 6, because this is for the nitric acid. However, for the nitric acid, we have here HO6. So let's see, 2, 3. Nitric acid is 6. Aluminum sulfate is let's see, aluminum 2, 2. Nitrogen, that's 3 times 2, 6. Is 6. Oxygen, that's 3 times 3 times 2 here, and then oxygen on the other's reactant, that's 3 times 4, 12. So there's 12, then that's 18. Okay, oxygen is balanced. Hydrogen, 3 times 2, 6. 6 for this. Okay, balance. Sulfur, that's 3. Then here, there's 3. And then here, there's 3. So this is balance. So your coefficient is 2, 3, 1, and 6. 1 because we considered there is a coefficient 1 on for this. And there's no need to put 1 because it's already considered that there is 1. Okay. For the last example, for the number 6, there is C4H10. This is already this is also a combustion reaction. Always remember that the product will be carbon dioxide and water. So we put the element, the left hand side, then the right hand side. So first carbon, hydrogen, oxygen. For the carbon, that is 4, there is 1. Hydrogen is 10, 2. Then the oxygen is 2. Oxygen here is 2, then 1. So there's a bit complicated in this side. So carbon here, we're going to multiply it by 4. So oxygen is affected, so we multiply it also by 4. And hydrogen, that's 10 times 2, most likely that's 5. Okay, so So we multiply it by 5 here. So hydrogen is already balanced, but for the oxygen, this is 8, this is 5, so that's 13. So we're going to multiply it by 13 times 2. However, we don't accept fraction, so we're going to multiply it by 2 overall. Okay? To make it balance. So for carbon, of course, we multiply it by 2, so 2 times 4. Then oxygen here, that's 2 times 2 here. So that means that's here we have 2 already, so 13. Okay, 13 here. So for the carbon on the right hand side, we multiply it by 2. 4 times 2, that's 8. Balance here. So this is really good. And then this one, that's 5 times 2, that's 10. So we're going to put here 10 for water. Let's see if we can balance. Carbon, that's 8, carbon 8. Hydrogen 20, that's 10, 10. Oh, sorry, here. 10 times 2, that's 20. Oxygen, 13 times 2, that's 26. So this is 8 times 2, that's 16. Plus 10, that's 26. So this is already balanced. So if you have any concern regarding the chemical equation balancing, you can comment on this post. And this is only a supplemental video for the chemical or the analytical chemistry on the topic for chemical equation. So good luck, and let's see each other on the next episode for episode 4 for chemical reactions. Good night.